In this tutorial, we are going to learn about cliques, and how to find clique in the graph. What is a cliques? Cliques is a problem in the graph theory to find cliques which has complete connectivity among k nodes in the clique. For an example, this is the simple network graph with 6 nodes connected with one another, and now let's find the clique 3 from 6 network graph using Google Colab. To find this, the conditions are, cost function of the clique should be 0, and qubit of each node should be 1. Let's do this using Google Colab. Firstly, install Blueqat using this code !pip install Blueqat. Now, open Google Colab and type the code. And click on the Run button here. Blueqat is successfully installed. Now, to do that, in Google Colab, we need to import Python modules called networkx and matplotlib.pyplot, which are the plugin libraries for Python programming language. We have to import libraries like import networkx as nx, and import matplotlib.pyplot as plt. We will use this code structure to generate the graph. This code is to import the libraries. This code will add node properties such as color, size and label. This code will create the empty graph. This code will create the graph with 6 nodes from 0 to 5. This code will draw edges from one node to another as shown here. Finally, this code will draw a complete graph with their properties as specified. Now, let us try this code to draw a graph in Google Colab and see how the graph look like with the given nodes and edges, and run it, then we will see the graph that is generated from the code. Here, the number of nodes are 6, so we prepare 6 qubits. And we try to find clique 3 and put 3 into k in the equation. Then, we will solve it using some matrix to prepare the first and second term separately. For this, let's import Blueqat optimization library as wq, and NumPy library as np. Import these libraries in Google Colab, and run them. Libraries are successfully imported. Since the coefficient of x0 nodes to x5 node are 1, and we prepare this as diagonal matrix, we store this coefficient in variable a, and then use the print function to print the diagonal matrix. Let's try this code in Google Colab. Here's the diagonal matrix. And using this, a, calculate 6a plus a squared using Blueqat's function. Here is the square of matrix A. By adding diagonal matrix A and square of matrix A, we can get the first term of the equation, that is matrix 1. Let's do it in Google Colab. Run the code. This is matrix 1. And we can get the second term simply creating QBO by hand. This time we try use b equal to 0.8. Let's do this in Google Colab. Here is the second matrix. Well, to get the QBO, we have to add matrix 1 and matrix 2. Let's do it in Google Colab. This is a QBO, and from this QBO we get the qubit value of each node. What we understood from this qubit value of each node is that, if the qubit value is 1, then it means that node has a complete connectivity with other node, whereas if the qubit value is 0, then it means that node does not have complete connectivity. From these qubit values of each node, we concluded that node 0, 1, and 4 has a qubit VLA of 1, which indicated a complete connectivity among each others, and that's where we found the clique in the graph. Thank you for watching this video.